We have a slab of aluminum that it's at the uniform temperature of 200 degrees C, and suddenly the surface temperature is lowered to 70 degrees C. And we are asked to find out what's the total heat removed from this aluminum per unit surface area when the temperature at the depth of 4 centimeters has dropped to 120 degrees. So what is known here? Initial temperature is 200 degrees C. The surface temperature is dropped to 70 degrees C. We have been asked to find Q0 over A when temperature is 120 degrees C at X equal to 4 centimeter. And Q is total heat to the system. And in terms of assumptions, we can assume this is a semi-infinite solid. It's a large slab, and only one side of that has a change of temperature. So if I want to plot that one or put a diagram here, let's say this is the slab of your aluminum, just a portion of this slab, and everywhere Ti is 200 degrees C, and we just change the surface temperature to 70 degrees C, and if this is the X 0, then let's say when the temperature at X equal to 4 centimeter, this is 0, 4 centimeter reach this temperature, reach 220 degrees C, then we want to see like how much heat has been removed from the solid to the surrounding medium here. So for aluminum, if the first thing is finding the properties, I'm gonna make another assumptions, constant properties. So if you read properties for aluminum, alpha is gonna be 8.4 times 10 to the power minus 5 meters square per second, and K is going to be 250 watt per meter Kelvin. Now for semi-solid, and the surface temperature changes to a constant T, which is different than Ti. We know the solution, the temperature at any X and T minus Ts, Ti minus Ts, is going to be in the form of error function of X over 2 square root of alpha T. Now, we know what is the surface temperature. We know X, we know alpha, we don't know time. So from here, we can find how long would it take the temperature at this X to reach 220 degrees C. So from here, we find T. So we know this temperature is going to reach 220 degrees minus 70 divided by the initial temperature 200 minus 70 is error function of X over 2 square root of alpha T. And this ratio, function of X over 2 square root of alpha T, this ratio is going to be 0.3847. Now in table B2 that I brought here, in order to have this error function 3847. So this is 3833, and this is 36936. So it's going to be between the two. So the W or the argument is going to be between 0.34 and 0.36. If you do the interpolations, then what you would get is x over 2 square root of alpha t, and that is 0.3553. And knowing the x, the location that we have that one, and alpha, we can find out t. T would be 0.04 meters, that's the location square, 4 times 0.3553 square times alpha. And from here, you can find 37.72 seconds. So what it means here is it takes 37.72 second for temperature at equal to 4 centimeter to reach 120 degrees C from 200 degrees C. So initially it was at 200 degrees C. Now it takes 37.72 seconds to reach there. Now the total heat removed during this time is going to be the integration of the flux that's getting at x0. So q0 over a is going to be the integral of 0 to any time, here 37.72 second, of flux divided by a dt, which is going to be 0 to t. And we know the flux for constant temperature semi-solid, a solid that has a constant temperature at surface, is going to be kTs minus Ti divided by square root of t dt. If you take the integral, you're going to get 2k Ts minus Ti square root of t over pi alpha. So if you do the replacement here, this is, let me just write it down. Flux at surface, which is x to 0. I'm just going to remove this 0 here, and even this q0. Let's call it q. At the surface, so q over a is going to be 2 times 215, which is k, times this delta t, 70 minus 200, times the square root of 37.72 divided by pi times 8.4 times 10 to the power minus 5, which is alpha. And this is going to give you minus 21.13 10 to the power of 6 joule per meter square, or minus 21.313 megajoule per meter square is removed from large slab. First, 37.72 seconds. The negative sign, what it means here is that the slab is hotter than the surrounding and is opposite to the x, like against the direction of the x or coordinate. So it means like the heat is just transferring from the solid to the fluid.